Hello and welcome everyone. This is Mohammad Izamam from SAIMEDHA ECET Coaching Center Koti, Hyderabad. SAIMEDHA Koti, Hyderabad is providing a golden opportunity to all the ECET 2024 and as well as ECET 2025 students. ఎవరైతే ఫైనల్ ఇయర్ లో ఉన్నారో, ఎవరైతే థర్డ్ సెమిస్టర్ లో ఇప్పుడు చదువుతున్నారో, SAIMEDHA Koti, Hyderabad is providing the online coaching and as well as offline coaching for it. Ranks గురించి చెప్పాలంటే SAIMEDHA Koti, Hyderabad లో every single time, every single year we have proven that maximum ranks in all the branches ECE, EEE, mechanical, civil and computer science లో top 5 branches లో state first rank తో పాటు maximum ranks in top 10 and top 50 లో కూడా maximum ranks are there. In this video lecture series in the YouTube, we are going to be updating every single day for all the branches subject wise and as well as topic wise. Previous ECET examination questions will be explained by expert faculties. My dear students, గుర్తుపెట్టుకోండి, ఓన్లీ ప్రీవియస్ ఇయర్ కాంపిటేటివ్ ఎగ్జామినేషన్ క్వశ్చన్స్ కొరకే సపరేట్ కోర్స్ ఉంటుంది, పే చేయాల్సి ఉంటుంది బయట మార్కెట్లో. కానీ SAIMEDHA Koti, Hyderabad లో ఫ్రీ ఆఫ్ కాస్ట్ we are providing that series guys in this very YouTube channel. So those who have not subscribed the channel, subscribe now and press the bell icon to be notified for the further more updates. Every day subject wise, topic wise, previous ECET examination questions with which you can understand the level of teaching, the expertise which is there in the SAIMEDHA Koti, Hyderabad. So my dear students, what are you waiting for? Start watching all the video series in this YouTube channel. At the end of the video, I'll be coming back to give you a surprise for all the ECET 2024 and ECET 2025 aspirants. So share this video as much as possible for all the final year students and third semester students. Now let's start the video. Now next one, the relation between modulus of elasticity, modulus of rigidity and bulk modulus is given by. Okay, so actually we are having three relations over here. What are that relations means? Listen carefully. As we are having the relation, so first we are taking relation between E and G. Okay, E and G. G means we have taken it as modulus of rigidity, or else we can take C also. C or N or G, C, N, G, like that we can take. So relation between E and G, modulus of elasticity and modulus of rigidity. So what we are having the formula means E is equals to 2G into 1 plus mu. What we are having? E is equals to 2G into 1 plus mu. Now if you are seeing this part means, now what we have to find actually, we have to find out the relation between three elastic constants. So first we have taken this part, E is equal to 2G of 1 plus mu we have taken. If you want to find out, sometimes what will happen, listen here carefully, sometimes this formula will be given or else it will be asking in the terms of mu. In the terms of mu means what we are having, Poisson's ratio. In the terms of Poisson's ratio also it will be asked sometimes. So let us see this part, what we can write for this. So what we are doing means, if you are sending this 2G part over here, it will be E divided by 2G, and we are sending this part means minus 1, means mu is equals to E divided by 2G minus 1. Okay, so either we have to remember this part or else we have to remember mu is equals to E by 2G minus 1. Okay, this is relation between E and G. Now let us go with relation between E and K. What we are taking? E and K. Okay, now let us see this part. What is the formula we are having for this? So we are having the formula as E is equals to 3K into 1 minus 2 mu. What we are having? E is equals to 3K into 1 minus 2 mu. This is the formula we are having. Or else if you want to write in terms of mu, then what we can write? Listen carefully. So first what we are doing means, E is equals to 3K into 1 means what? 3K we have taken, plus into minus 3 2s are 6K mu. Okay, 6K mu, like this we have taken. Now listen here, as we have to find out mu value, so first we are sending this minus 6K mu over here and we are sending E over there, means it will become what? 3K minus E. Okay, like this we have taken. And what we are having, 6K mu we are having on the left side. So if you are having 6K mu, we want only mu over here, so divided by 6K. Okay, so mu is equals to 3K minus E divided by 6K. Okay, so this was a relation between E and K. Now last relation what we are having, so relation between E, G and K. Okay, modulus of elasticity, modulus of rigidity and bulk modulus. What we are having? Bulk modulus. Now for this we have to write the formula what we are having. So E we are having, E is equals to
9 kg divided by, if you are taking this part as k plus 3, k plus 3g, 3k plus g, we are having this part as a 3k plus g, okay. So 3k plus g, this is the formula we are having. E is equals to 9 kg divided by 3k plus g, okay. So according to this formula we have to remember over here E, g and k. Now again for this part also, sometimes another part will be given over here, another formula will be given. What is that another formula means? Listen here carefully. Suppose if you are doing reciprocal of this means what will happen? This E by 1 will become what? 1 by E. So if you are writing 1 by E over here, 1 by E, it is equals to, this also will become reciprocal means 3k plus g we have taken, 3k plus g divided by 9 kg. Divided by 9 kg means we are splitting the denominator, divided by 9 kg we have taken, and over here also divided by 9 kg we have taken over here, okay. So this part we have taken. Now next what we are doing means, let us do one thing over here. So this 9 we are having, let us take 9 as common and we are sending to this part. If you are sending this 9 over here and we are sending to this part means it will become 9 by E, it is equals to, this part will become kk gets cancelled, 3 by g and this gg gets cancelled, plus 1 by k, okay. We are having this formula also, 9 by E is equal to by g plus 1 by k. Now let us take the options what we are having over here. Let us take the options what we are having over here. So E is equals to 3k c by c plus 9k, E is equals to 9k c by 3k plus c, E is equals to c plus 9k by 3k c, E is equals to c plus 3k by 9k c, okay. So if you are taking this formula only, if you are applying this formula over here, what we are having, 9 kg means we are writing this part as E is equals to 9k, in the place of g what we have to write c, okay, because this modulus of rigidity means we can write it as c or n or g, anything we can here. So 9 kc divided by 3k plus c means which option will be correct now? Second option, okay. So E is equals to 9 kc by 3k plus c means second option is correct. Now let us go with the next question. Principal plane is a plane on which a shear stress is. Now what is the meaning of principal plane over here? Now this principal planes topic, principal plane and principal stresses topic, it is under complex stresses and complex strains, okay. So first we will discuss what is the meaning of complex stresses over here. Suppose we have taken a body, okay. Now listen here carefully. We have taken a body over here. Now in this we are having the normal stresses. What we are having? Normal we are having sigma x, normal stresses we are having over here, and we are having this part as a sigma y, okay. So this part we have taken it as a normal stresses. Normal stresses means what? Perpendicular to the cross section, okay. Normal we have taken. Now in addition to the normal, if you are having shear also, what we are having? Shear means what? A parallel to the cross section. Suppose we are taking this part as a shear, okay. This is shear we have taken. So if it is in right direction, we have to take this part in what? Left direction, okay. This is right, this is left we have taken. Now if you are seeing this one, this is trying to rotate. If you are applying the shear, it is trying to rotate like this in the clockwise direction. Now if you want to make it as a stable, then what we have to do, if it is trying to rotate in clockwise, we have to apply complementary shears in the anti-clockwise. So if you are applying in anti-clockwise, this is upward we have taken and this is what? Downward, okay. So now the body will be in what? A stable condition. So whenever we are having normal stresses as well as a shear stresses, combination of normal and shear, then we are calling it as a complex stresses. What we are calling? Complex stresses. But what is the meaning of principal now? What is the meaning of principal means? In this complex stresses, whenever the shear stress it is equals to 0, what we are having? Shear will be 0. If you are taking shear will be equals to 0, then that we are calling it as a principal stresses, and that plane we are calling it as what? A principal plane. So principal plane, it is a plane on which a shear stress will be equals to what? 0. If the shear stress is 0, then what we are having? We are having only normal stresses, okay. So we have taken that part. So this plane or stress we are calling it as what? Principal plane or principal stresses. Now, next question. The elastic force at a distance y from support in a vertical hanging bar of length L which carries a load of P at the bottom is equal to. Now, this is also a very simple question. It is coming under actually self-weight deformation topic. Okay, self-weight deformation what we are having. Let us see this part first. So, from the support, let us take this part as a support we have taken over here. This is support we are having, and we are having vertically hanging bar. Okay, so this is vertically hanging bar we have taken, and the length is what? L. This complete length is L we have taken. Complete length is L we have taken over here. Now, next what we are having means the elastic force at a distance y from the support, distance y from the support. Suppose this we have taken this part as y. If this is y, then the remaining will become what? Remaining will become what? L minus y. Okay, we have taken this part as L minus y, which carries a load P at the bottom. Now we are having this part as P. P load we are having at the bottom. Okay, now we have to what we have to calculate over here? Elastic force. We have to calculate force over here. We have to calculate the force which is equal to. Now we have to calculate from this point. We are calculating from this point. If we are calculating from this point over here, so what already we are having the load. So let us take this part as P. First P we have taken, then plus we have to consider this part also. Self weight also we are considering over here. If we are considering the self weight, now what we are having specific weight we have taken it as W, and per how much length we are having, how much length we are taking, L minus Y. So we are taking this part as L minus Y. Suppose if it was selfless, means massless. If you are taking this part as massless means then we can consider only P over here. If you are considering this part also, then P already we have taken, then we have to consider this region also, means specific weight we have taken up to how much we are having, how much length we have taken means L minus Y, up to this length only we have to take means L minus Y. Okay, that part we have taken. So P plus W into L minus Y means the third option. Third option is correct. The point in the stress versus strain diagram at which the cross sectional area of the test specimen starts decreasing is called, okay, elastic limit, upper yield point, lower yield point, ultimate stress point over here. Elastic limit we can't say over here. Over here what is happening means stress is directly, means in this region stress will be directly proportional to strain, that is proportional limit, and in elastic limit the body can have the capability to regain its original shape and size, that will be called as what? Elastic limit. Okay, now upper yield point, lower yield point, ultimate stress point we are having over here. Now let us discuss in the diagram what we have drawn over here. First we have taken this diagram now. So if you are seeing the diagram, now first C point we are calling it as what? Upper yield point, upper yield point. Okay, now after this, beyond this C point, beyond this upper yield point, what is happening means you can see this part. It is we are having the curve which is moving in upward direction. We are having this curve is bending upward. It is bending what? Upward. We are having upward curve over here. So what will happen means whenever it is going beyond this yield point, if it is going beyond this yield point, we are having the cross sectional area, actually the cross sectional area will be decreases. Whenever after crossing this C point, the cross sectional area will be decreases, and whenever we are having decrease in that cross sectional area, we will be getting some neck point over here. What we are calling this point as neck point. At this neck point, it is having the maximum stress it can handle. This point we are calling it as what? A neck point. After this, if you are having decrease in the stress also, if you are having decrease in the stress also, strain will be increases. What is happening? Decrease in the stress means strain will be what? Increases. Whenever the strain is increasing, we will be having the failure point. Okay, so we have to remember one point over here. Beyond this C point, the cross sectional area will be what? Decreases. Decreases means it is becoming thin and thinner. If it is becoming thin section over here, so we are getting the neck point. After neck point, if you are decreasing the stress also, we are having the strain over there. If you are having strain means then we are getting what? Failure point. Okay, so which point we can remember over here means upper yield point. We have to remember it as a upper yield point. So the point in the stress versus strain diagram at which the cross sectional area of the test specimen starts decreasing means which point we are having over here? Upper yield point. Option 2 is correct. Now next, the percentage elongation for a ductile material are usually, ductile material means I will give you some standard value over here. For ductile means we are taking the example as a mild steel. If you are taking the example for mild steel, what is the percentage elongation we are having for this mild steel means it will be approx like 20% to 30%. What we are having 20% to 30% for mild steel as it is a ductile material. So what are the options we are having over here? Less than 5%, 5 to 10%, 10 to 15%, more than 15%. More than 15% means let us go with the fourth option. Okay. Now next question. In a strained material subjected to two normal stresses, the maximum shear stress is equal to. Now maximum shear stress is equal to. Now in this part we are having one formula, tau max. Tau max, it is formula as under root sigma 1 minus sigma 2 by 2 whole square plus tau square, tau xy whole square. Like this formula we are having for maximum shear stress. So as we have taken that part of principal stresses, principal strains, complex stresses, complex strains, in the topic only we are having this formula. Now what is given means in a strained material subjected to two normal stresses, we are having only two normal stresses over here. We are not having any shear stress. If you are not having tau value, then tau will be equals to what? 0. If tau is equals to 0, then what we are getting? Sigma 1 minus sigma 2 by, then it will become what? Tau max. Tau max, it is equals to under root sigma 1 minus sigma 2 by 2 whole square. So this square root gets cancelled. Now what is the answer we are getting? Sigma 1 minus sigma 2 divided by 2. Means sigma 1 and sigma 2 we are taking it as what? Normal stresses. Okay. Now let us discuss this options what we are having. Sum of the normal stresses, difference of the normal stresses. Okay. Means we are having always sum of the normal stresses means sigma 1 plus sigma 2, like this we are having. Difference of the normal stresses means we are having sigma 1 minus sigma 2. Okay. Like this we are having. Half of the sum of the normal stresses means sum of the normal stresses means sigma 1 plus sigma 2, half means divided by 2, like this we have taken. Half of the difference of the normal stresses, difference means what we are having? Sigma 1 minus sigma 2, half means divided by 2. Okay, so these are the four options we are having. So as per our simplification, what is the answer we got over here? Tau max. Tau max means maximum shear stress, it is equals to how much? Sigma 1 minus sigma 2 by 2. So over here sigma 1 minus sigma 2 by 2 means fourth option. Fourth option is correct. Now next, loaded is dash the strain energy stored when same load is applied gradually. Means we are having again same relation as a sudden applied, suddenly applied and gradually applied. Okay, so we have written some formula over here now. So we are having maximum stress induced, maximum. So what we are having sigma, it is equals to what? P by A for what? Gradually applied load. Similarly, sigma is equals to 2 into P by A for what? Suddenly applied load. Okay. Similarly, sigma is equals to P by A into 1 plus under root 1 plus 2AEH divided by PL. Okay. This is for what? Impact. So this three formulae we are having over here, directly we have to remember this three formulae, gradually P by A, suddenly 2P by A, and this impact means impact, again I have told you H, if H is equal to 0, this complete part will become 0, we are getting 1, root 1 is equals to 1, 1 plus 1 is equals to 2, 2 into P by A, it will become what? Sudden. Okay. So in the impact condition, if you are taking H is equal to 0, then it is becoming what? Sudden. So what is the relation between suddenly and gradually means we are having twice, 2 times, 2 into P by A, 2 into P by A means twice of the gradually applied load. So twice means let us go with the third option over here. Next, the phenomena under which the strain of the material varies under constant stress. Under constant stress, we are having constant stress over here. Constant stress is known as constant stress we are having. Okay. So what will happen means we are having creep, strain hardening, Bochinger effect and hysteresis we are having over here. So what is the meaning of this part? So whenever we are having strain, under constant stress, means we are having one definition, one property, slow and progressive deformation. Slow and progressive deformation. slow and progressive deformation with time under constant stress. Okay, so we are maintaining constant stress over there. Stress is not changing, but depending upon the time, with respect to time, what is happening over here? We are getting slow and progressive deformation. If you are getting deformation over there, it will be related to what? A strain. So under constant stress with respect to time, we are getting the strain over here. Then we are calling it as what? We are calling it as creep. What we are calling? We are calling it as what? Creep. Okay. So over here also what is given? The phenomena under which the strain of a material varies. Strain, slow and progressive deformation, strain. It is varying under constant stress. So we are calling it as a creep. First option is correct. Now next, a 2 meter long rod of material having modulus of elasticity E value is given, coefficient of linear expansion is given, is heated from 20 degrees Celsius to 90 degrees Celsius is given. If the expansion due to temperature rise is prevented, the rod will develop a compressive stress equal to, means we have to find out the stress value over here in the terms of what? Mega Newton per meter square. We have to find out stress over here. So what is the stress formula we are having over here? What is the stress formula? Compressive stress or thermal stress formula, what we are having? We are having it as alpha delta T into E. Okay, this is a formula for stress we are having over here, alpha delta T into E. Let us substitute this. What is alpha value we are having? 12 into 10 power minus 6, 12 into 10 power minus 6 we are having. Then delta T means change in temperature. Change in temperature means T2 minus T1, 90 minus 20 is equals to 70. So we have taken 70 into, this is also degree Celsius, this is also degree Celsius we have taken, no need to change into Kelvin. Okay, 70 we have taken. Now what is E value we are having? 100 into giganewton per meter square. So we have to convert it into Newton per mega we have to convert now. So first let us write as giga. What is giga we are having over here? 10 power 9. Okay, we have taken this part, 10 power 9 we have taken. Now whatever the answer we are getting over here, we will be getting the answer in the form of Newton per meter square. Okay, now let us simplify this what we are having. So this 10 power 9, this 10 power 6 we are having, 10 power 6 gets cancelled. Now what is remaining? It is equals to 12 into 7 into, now how much we are having over here? 6 is gone, means 3 is left. This is 3, 4, 5, 6 means 10 power 6 Newton per meter square. Okay, like this we have taken over here. Now next let us multiply this, 12 into 7 means how much we are getting over here? 84. We are getting the answer as 84. Now 10 power 6 means what we are having? Mega Newton per meter square. So this is the final answer we are having. Okay, so if it was, listen here carefully, if it was only Newton per meter square, mega is not given. If it is only asking Newton per meter square, so if it is asking Newton per meter square means this will be the answer, 84 into 10 power 6. As it is asking in mega Newton per meter square, then the answer is what? 84. The answer is only what? 84. So which option will be correct now? Third option. Okay, third option is correct. Now next, the Poisson's ratio for cast iron varies from, again cast iron just now we have taken over here, all that values we have taken over here. All that values we have written for Poisson's ratio, this part. So cast iron what we are having? 0.23 to 0.27. Okay, 0.23 to 0.27. First option, 0.23 to 0.27. The question is repeated over here again.
So my dear students, for ECET 2024 and ECET 2025, SAIMEDHA KOTI Hyderabad is providing maximum concessions in this very week. Offline students gavachu, online students gavachu, online plus offline students gavachu, morning batches, evening batches, day batches, full day batches, online courses with materials gurinchi SAIMEDHA KOTI Hyderabad in this very week, guys. In this very week only, we are providing the maximum concessions. Concessions evaithe unnayo, concessions ఏ విధంగా ఉంటది, batches ఏ విధంగా ఉంటాయి, ఉంటాయి, విత్ మెటీరియల్స్, వితౌట్ మెటీరియల్, ఆన్లైన్ కోచింగ్, టోటల్ మీకు ఏ డౌట్ ఉన్నా సరే ఆ కన్సెషన్స్ మాక్సిమం ఏమున్నాయి అంటే మనకు మొబైల్ నంబర్స్ ఇక్కడ స్క్రోలింగ్లో ఆల్రెడీ ఇవ్వడం జరిగింది. సో స్క్రోలింగ్ అవుతున్న మొబైల్ నంబర్స్కి కాంటాక్ట్ చేయండి అండ్ జాయిన్ ఇన్ ద సాయిమేధ కోటి హైదరాబాద్ as soon as possible. Don't miss this opportunity of getting the maximum concessions, guys. Thank you very much. In this video series, every single day we are going to be updating subject wise, topic wise, previous ECET examination questions. I wish you all the best. This is Mohammad Inzamam signing off.